Okay, so last lecture we have seen the hydrostatic law, and we've seen the hydrostatic law, and we'll see the density variation of the fluid, and we'll get some equation regarding this. For the isothermal fluid, we'll get some equation for the compressible, adiabatic compressible fluid. This kind of the things we have seen. And the concept of the lapse rate, the last topic it was. So what is the problem? Just 1 minute. So the last portion we are getting here, T is equal to, so what we get, T and T relation. So T is equal to T0 minus something into Z, some constant into Z. So this alpha is known as the lapse rate. So if we change the Z, at that rate the temperature will be changed. And what is that values? This value will come in there, gamma minus 1 by gamma G by R. You can check whether it is coming on from the same calculation. So this is known as the lapse rate. So last day we are considering is the most thing. Now today, and hydrostatics law also you are writing it here. dP, the P is only varying along the Z axis because there is a gravity is the only body force, and this is rho G. This is the hydrostatic law, very important laws. Today we'll see the force exerted in the plane surface immersed in the liquid at rest. So here, the liquid, inside a liquid, one solid body or plane surface is immersed condition. So how it is looks like the solid body in the cross section wise, if you see, is like this. Cross section wise, it is like this. Just you see one plane surface. The surface is a plane. If you see the cross section, it is like this. So what is the force is acting over it? If you consider, just think, here in this point, you see from the free surface, if you go as much as deeper, your pressure is increasing. Because from your hydrostatics law, you have seen it, dP dz is equal to minus rho g, where rho g you take it as a consideration, and ultimately doing integration, you are getting these values. So you are from the free surface, how much depth you are going, the pressure will be increased. So this portion, top of the portion, is the less depth. So there is some less pressure, and here in bottom of there is more pressure. So as the pressure variation is there, so force variation will be also there. So pressure variation is like this way. The trapezoidal. In this way, the pressure is varying. So different place, there is a different pressure. Due to cause of this variable pressure, we have to find it out what is the total force is exerted over the plane surface, and what is the force values and where it is acting. This is our consideration. So this we will consider now. So let you see first cross-sectional area. We just again draw the cross-sectional area here. This is the cross-section plane surface. Now here, if you consider one small elemental area, this axis is taken as the x-axis, and this axis is taken as the y-axis. And this plane surface is at theta degree angle. The inclination of this plane surface, the inclination angle is theta. If the plane surface is horizontal, so theta value will become 0. If plane surface is vertical, the theta value will become 90. So for generalization purpose, this is for the horizontal plate, this is for the vertical plate. But to generalize this situation, we are taking some inclination angle theta. So from the x-axis consideration, the perpendicular to this plane. So this angle, this is from the x-axis, it is y. At y distance, you consider it at dy element. At y distance, you consider one dy element. And in the cross section wise, how it looks like? It looks like this. That is nothing but dA. Small area. dA. So what is the pressure is acting over here? Let you consider the PA. We are considering only here gauge pressure. Atmospheric pressure we are taking as a reference. So basically P minus PA we will consider. So what is the height of it? From the depth, what is the depth of it from the face of it? That is h. So your formula, if you take the sine theta, you will get it h by y. So you will getting it here, h is equal to y sine theta. So what is the pressure is over here acting? Let you gauge pressure we are talking about. So what is the pressure is acting? So from your hydrostatic principle, P minus PA is equal to rho GH. So rho G y sine theta. That is the pressure is acting. So what would be the force? Force would be this pressure, gauge pressure into area. So this pressure sine theta into area. Area is the dA here. So that is the elemental force is acting only over this plane. PF. Only over this plane. So throughout the plane surface, what is the total force is acting? The total force exerted throughout the surface. If you have to do the integration with respect to the total area. Total area is A. A is the total area. With respect to this total area, the integration. So rho is no dependency with the A, dA. G is also not having any dependence with the A and sine theta. So rho, G and sine theta have no dependency with the area. So it will come out of the integration. Rho G sine theta. And remaining portion is the y dA. So what is y dA? Y dA, better to say the first moment of area. We are writing it down. First moment of area. If you remember, recalling the moment of inertia chapter and centroid finding process, you will see that y dot dA, if you consider one small area, so it is nothing but the total area into the y distance of the centroid. So where is the centroid? Let you take here the centroid of this. That is the C. So this is the YC. This is the YC. Centroid at here. Here it is centroid of the plane surface. So this is the YC. So F value, the force exerted on the plane surface immersed in the liquid at rest is rho g sine theta yc into A. So rho g A into y sine theta, yc sine theta. So yc sine theta means here there is a yc. So depth is the hc. So yc sine theta is nothing but the depth. Because the same formula, hc by yc, sine theta is equal. So rho g A hc. That is the force exerted on the plane surface immersed in the liquid. So again, I am writing it, the total force exerted, rho, density of the fluid, g, gravitational acceleration, area into h. You have to finding out the centroid of the plane surface and depth from the free surface one. That much amount of the force will be acted. You may ask in the pressure why we take it the force in this way, P minus PA into D. Because due to the atmospheric pressure, always some force is acting over us. So whatever the extra force we are considering here. So that's why P minus PA into A, not PD. Because of that, we are all, everyone is under the atmospheric pressure force due to the atmospheric pressure. We are all, we withstand this force always. Whatever the excess of it, we are considering. So here the excess is considering. So that is the surface. Now where this force is acting, whether it is acting centroid or different place. So one definition is coming, the center of pressure. The center of pressure is telling that the resultant force passes through a point is known as the center of pressure. In such a condition, what is the resultant force? Whatever you are getting, what is the resultant force you are getting? Rho g A H C. This resultant force passes through a point is known as the center of pressure. So there must be some point over through the total resultant force is passing. The total force, if you are replacing the total resultant force in a point force, it will act over a point. This point name is the center of pressure. How could we find it out? We can find it out same way. Just first we considering the same thing. Our surface was like this way. Again, we have to go for the Varignon's theorem. You know the Varignon's theorem? We are talking about Varignon's theorem. So what Varignon's theorem is telling? Varignon's theorem is telling here, initially what we consider, that is y dy, small elemental area we are considering here initially. So what is the force was acting? The force was acting, if you remember, the elemental force was acting. The elemental force was acting here, dF. We are not writing now the value. dF, because of this force, it creates some moment about this x-axis. So the force create one axis, a moment, about this axis, that is dF into y. So there are numerous forces there, enormous number of forces there. So total, if you integrate, the summation of all force creating the moment about the axis will be equal to the resultant force F, which is acting at the center of pressure. Some places, that is YP. YP. We're finding out the YP. Where is the location of this YP? We are finding out from here, Varignan's theorem. So Varignan's theorem is telling, in a system there are a number of forces there. So about a particular point, the moment of all forces will be equal to the moment of resultant forces about the same particular point. That we are considering here. So elemental all forces about the x-axis. So that's why we are putting it here integration. So dF already we have seen the previous cases, dF value, rho g y sine theta into dA. Here you see the dF value, rho g y sine theta into dA. We are putting this thing. Rho g y sine theta into dA. That is the dF into another y. We are considering. So F into YP is equal to rho g y square sine theta dA. Rho g and sine theta not depends on the area. It will come out of the integration. Sine theta y square dA. We are considering here over the integration over the total area. So y square dA integration, what is that? This is called the second moment. Initially it was the first moment of area, it is second moment of area. Or loosely we are telling it, moment of area, moment of inertia. Area MOI. About x-axis. So Ix. Very loosely telling it. So that is nothing but the Ix. And F value we are getting it previously, rho g a yc sine theta. HC we are writing it yc sine theta in terms into yp. So here rho g will be cancelled out and sine theta will be cancelled. Rho g sine theta will be cancelled. So a yc yp is equal to I. That is the remaining. So what is the YP? So YP, center of pressure Y location is Ixx into AYC. Very, very important formulas. We initially got the centroid. We initially got centroid C here, somewhere else. Now parallel axis theorem, if you apply, the parallel axis theorem is telling that Ixx is equal to I of centroid or Ig, center of gravity. If you same parallel line, if you pass through the center of gravity, parallel to the x-axis. If you one axis passing through the center of gravity and which is parallel to this axis, plus the total area of the substance or plane surface into the distance between the two axes, that is YC. We are considering initially centroid to x-axis, that is YC. So A YC square. That will becomes A YC. That is the parallel axis theorem. So if you put it here, YP is equal to Ig, moment of inertia, area moment of inertia or second moment of area through the gravity, center of gravity or centroid, by AYC plus YC. that will come. So what is coming, we just list it out now. Now I remove all this thing. Now what are the things is coming, I list out. Your force has been came, total force acting over it. Rho G A YC sine theta, or you can tell it like that, Rho G A H C. Same thing. Where the force is acting, that is YP. So YP is equal to YC plus I center of gravity, IG or ICG, you can write it AYC. What does it mean? YP is greater than YC. So center of pressure, so if C is at here, so P will be at here. Y location. If it is the YC, so YP is more than this. That is the concept here. So depth is also more. That is the HC. So depth from the free surface is also more at the center of pressure. Because IG is not equal to 0 and positive term. Area is a positive term, YC is also a positive. So hence it is YP greater than YC. That is the consideration. So we have seen this thing. What about the XP, x-axis? Because the x-axis concept is coming in this way, just the same Varignin's theorem will apply here. So Varignin's theorem, if you remember this thing, so what is the dF elemental force was acting, and initially it was let you take x. From the x-axis, it is x. This is not the x-axis, let there somewhere else x-axis. And from that, there is the x. So that should be equal to the total force into x. From the Varignin's theorem, we are getting simple. Just put the value here. Rho G Y sine theta is equal to Rho G Y sine theta A. If you see this, Rho G sine theta will come out of the integration. So Rho G sine theta will be cancelled out from both sides. Remaining part is x, y. Remaining part is x, y, and dA is the remaining part. Is equal to A is the YC, definitely. I write it wrongly. AYC. So XP will come. What is this? Over the area. If you remember the moment of inertia chapter XYDA about over the area, that is the known as the product moment of inertia of the area. Product moment of inertia of the area. Or why product moment of inertia is required? Because to check the symmetric, whether the plane surface is symmetric or asymmetric. For this purpose, product moment of inertia can be equal to 0. If the body is symmetric over the axis, the product moment of inertia will come as a 0. So that is not a factor. So better we are writing it this thing IXY. IXY is the product IXY divided by A. The product moment of inertia also can be the parallel axis theorem you can apply here. IC CG or CG plus area into X, XC into YC. Sorry. Because the centroid. For centroid to the axis, what is the distance square. So hence here it will comes xp is equal to ig ayc plus x. So another equation comes. So xp and yp we can finding out. So we can get the location of the p, proper location of the center of pressure. In a coordinate system, xp and yp both we are getting in this way. So that is the concept of the pressure is coming in this way. And for the plane surface, we can finding out in this manner. So this is the concept we are telling about, the concept of the pressure. So what are the things? The force over the plane surface, you are getting these values, rho g a hc. So no doubt about the force. If you know this all the things, you can getting the force. What is the yp? Yp is equal to yc plus ig ayc. If you multiply this thing with the sine theta component, both sides, because you know that is the sine theta is equal to, what is that? Sine theta is equal to hc by yc, hc by yp, all is equal to sine theta. So you are getting yp is equal to hp, yc is equal to hc, ig sine theta, a by hc by sine. So hc plus ig sine square theta into ah. Sine square theta into AAC. That's why we can say HP is must be greater than HC, because IG cannot be positive, cannot be negative. Sine square theta cannot be negative. These are a positive term. All are a positive. This is the influence of it. So it is more important HP greater than HC than YP greater than YC. It is more realistic to understand, because sine square theta is a positive quantity, Ig is a positive quantity, A is a positive quantity, H is a positive. So that is the way to get this. So you remember these values. If you apply for the depth, you apply this with the sine square theta. If you apply the YP, you apply this. Hence, the case 1, horizontal plate. Horizontal plate. Horizontal plate, theta is equal to 0. So as the theta is equal to 0, so E plus Ig is simply it is coming. Your sine square 0 is equal to coming 0. Sine square 0. It is 0. So HP and HC are the same place. If a plate is horizontal, the centroid position and center of pressure position from the depth is the same. No change. In case of the vertical, plate, theta is equal to 90 degrees. In such a cases, the HP is equal to HC plus IG A. Because sine square theta, sine square 90 is equal to 1. So this will be for the vertical. So vertical plate, definitely the depth of center of pressure is more than the depth of center. So here, this up to this about the concept of the center of pressure. Any kind of the problem is asking regarding this, you can getting it. how easy kind of the problem. I just want to show you just some cases before. Simply this kind of the problem if you're asked. A hinge gate of the length of the, here length is given 5 meters. One gate is here. The length is given as the 5 meters. It is inclined at the 30 degrees. 30 degrees. So, what is the pressure is acting? Because here different pressure is acting. This kind of the problem will solve it. And before going to the solve the problem, just conceptually I'm telling it to you. That is, if the from the free surface, better to go this letter. The free surface, if any surface is given to you, rectangular surface, that you take it's 5 meters, is a 2 meters. So where would be its centroid, and from the free surface, it is 2 meters. So what is the force is acting over it? Simple thing. If you are asked, that it is a water. It is a water. So water means density. You can consider 1000 kg per meter. Simple question we can first try. So here, where is the location of the centroid here? So location of the centroid is at here. What is the depth of the location of here? So HC 2 plus 2 by 2. So area 5 into 2, 10 meters square. So what is the force is acting? Rho G A H C. Simply you put it 1000 into 9.81 into area into H. This much of newtons is acting. So if you can write it down also 1000, so 30 into 9.81 kilometer. So nearly 300 kilonewton. Near to the 300 kilonewton is acting over the plate. What is the location of the cases? Is a vertical plate. What is the location? So location, if you are going to finding out, so location formula, you just HP, height of the pressure, is equal to HC plus IG, H. Just formula. HC you know is 3. What about the IG? IG to be taken, your axis in this. So it should pass the CG. Here the concept to take the IG. It should pass the G. So whether it is this one or center, which axis we have to take? Whether this axis or perpendicular to the plane. So this is the concept we have to follow. Previous case, if you see here, we are taking the parallel axis theorem. We are considering about this axis and parallel to this axis, which is going to the centroid. This axis we are considering previously. Now theta becomes 90 degree. So theta becomes 90 degree means if the theta becomes 90 degree, the whole system, if you rotate 90 degree, so x-axis will come horizontal. If you rotate the system 90 degree, so x-axis will come horizontal. Just imagine. So this axis has to be considered here. This axis, not this one, not this one. We have to consider this axis. There's a sense of rotation. So about this axis, what is the, because rectangle as it is 5 into, it is cutting that 2. So 2 cube divided by 12 into area. Area is the 10 into 3. So this is your answer. So 5 into 2 into 2 into 2 is the 40. So 40 by 12 3 into 10. So 3 plus 1 by 9. That is so 3.11 meter distance. So somewhere else is the P, somewhere else is the C. So this how we are getting. But concept what I am giving, which axis you have to consider in such a situation. That is this axis. So any kind of problem, if you're giving in this kind of thing, so you have to search for the HC, location of the HC. If you could be able to find the HC, you can get the force. You will get the force. After getting the force, the location of the force, at what location is there, that you have to get it. So the previous problem, what we are considering